thank you. This was the time for our questions, and I will ask the authors to turn on their videos now and unmute themselves to turn it into a panel discussion. So please, from the attendants, if you have any questions for our panelists, please unmute yourself and well, raise your hand so you can unmute yourself and ask the question. And to kick it off, I'm curious for everybody on this in this group really, but maybe more specifically for Huaichang. So this is it. I think it's a very nice idea, but I was wondering how this solution would adapt to having something like a more layered storage system. So, for example, if you would have like an opt-in cache in front of this system, would it still affect? Would your solution make sense to mitigate tail latency in that case?
Mm-hmm. Yeah, that's a great point. So we do have some discussions in our paper about this point. So I think the high-level answer is that, with opt-in cache serving as a cache layer, so the average latency can be, significantly improved, but the tail latency is not going to simply go away. So that's simply because, when you have background buffer flushes, and those writes will, go to the deep storage layer, which will can eventually trigger a lot of background GC activities, and under those cases, you will still suffer from tail latencies. I would say that for those cases, so probably the percentage of a tail that I see is much smaller, compared to a no caching layer case. But the problem is still there, and we still just tackle it. Under that sense, Yoda is still works for those scenarios, to tackle the device level tail latencies. Does that make sense?
No, yeah, that does make sense. It's a good answer. I believe we have one question here. I saw Bogdan raise his hand.
Hi, everybody. I don't know if you can hear me. Okay, I'm unmuted. Yay, I managed. Sorry, my audio got cut off, so I'm not sure if this question was answered, but I had a, or asked in a different shape or form. I had a question for Huaichang, for Yoda, actually. So if, I'm not a storage person, so my question might sound silly, but it sounds like Yoda does some device level changes. And I was wondering if you looked at, or you have some insights about how Yoda can be implemented on commodity SSDs.
Yeah, so one of the design principles that Yoda target is to touch minimal on the device side, so for easy deployment. And what we have changed on the firmware side is relatively simple. So the firmware just needs to handle our extra interface changes, to pass those fast file signals, and to advertise the time window lengths, back to the host layer, and we leave most of the complexity to the host operating systems. So with this, we hope that considering that PRM interface is already standardized by the NVMe community, and with our small changes, that it can be deployed in the near future, hopefully.
Right. So there's not some huge change that the industry has to implement, and it's always difficult to do that. Awesome. Thanks.
Yes. Thank you for the question.
Thank you. Are there any other questions for our panelists? Yes, Roman?
Sorry, yeah. I had a question for Kangaroo. So my question is that the threshold for dropping objects in Kangaroo is not actually dependent on the frequency of accesses, right? It is dependent on whether that object fits in a set or not, along with other objects. So because of this, did you in real traces, did you find, did you observe any cases where you had to kick out frequently accessed objects or something like that? And So did that like reduce the cache, make the cache miss ratio worse?
Yeah, so you're right. The threshold admission policy only applies to basically how many objects exist in Klog that map to the same set in Kset. And so we can potentially drop objects and evict objects out of the cache entirely that are popular. The way we prevent doing this is we actually will keep some information around about how many accesses an object in Klog has. So that if we're going to be evicting a really popular object, we can readmit it into Klog and rewrite it with the next set of items moving into Klog so that we don't have as large of a miss ratio penalty for having the threshold admission. And we rewrite it to Klog because it's much cheaper in terms of the number of writes we have to do in order to put it back into Klog.
I see. Okay, thank you. And I had a kind of a broad kind of question for anyone who could answer it. And my question was that the talks in this session are basically like focused on modern storage devices, right? So my question was that this might not directly apply to Flash, but we see that even more modern storage devices like maybe persistent memory and stuff like that have very unique characteristics of in terms of performance, about their latencies and bandwidths and so on. And so my question was that when you design systems, should we take these characteristics of these hardwares into account while designing systems, because that provides us good performance for that hardware, but it might make it narrow because there are the new vendors that come up with new forms, and that might completely like invalidate all the design decisions you make for this particular hardware.
I think I can go first. Yeah, I think that's generally a great idea to always consider, the device level performance characteristics when you design, systems on top of that. And actually, for my research, one core theme that I have been focusing on is, to look at, what performance, characteristics, different hardware we expose, and, to handle that, from the system side, accordingly. What the benefits that it gives us is that, when you design systems specifically, for those hardware, well, it can potentially help us, hide the performance, peculiarities, and, better expose the performance promised by the device to the applications. On the other hand, it's not just about, when you design one specific scheme, for the performance characteristic, of one type of device, but rather I think, this approach can be generally applied, to different type of devices. For example, for the UNA work, so although we focus on NAND flash, we don't think that our idea is only applicable for NAND flash. The fast file signal, it can be generally helpful, for different type of I/O devices, or even the narrowing cards. When the I/O device is busy, so with this kind of fast file signal, well, it gives us a better decision point for the host decide to know, when the performance is bad, and so the system layer can react accordingly.
Yeah, that's a great answer. Thank you.
Oh, can I talk about it a little bit, that subject? So actually, if I'm right, you're asking about like, should we design a system for specific stuff or some general case or something? I think it is like different, because if you're dealing with byte addressable like stuff or block IO stuff, because as far as I know, like especially recent SSDs just utilize like parallelism so much. So I think it's just better to do like excessive, like fill up the IO queue as much as possible, and like big chunk IOs as much as possible. I think there's a solution. There's no other way. Or maybe if somebody says like, oh, maybe sequential IO is better for garbage collection or something, that also matters. Like that is important too. I also think so. But on the other side, like persistent memory, actually we use a little bit differently. Like we don't use block. I mean, we sometimes use, but usually we don't use like byte addressable way, or we also utilize the persistency or something. So I think like we shouldn't think that as just traditional storage. We need to think like entirely different, and we need maybe like a different kinds of methodology for evaluation, different workloads. More, we need to explore something else. But I think at least like in the case of storage, like as I say, like block devices or something, I think it's better to like design some general stuff. Anyways, like that they are actually go through abstracted by operating systems or block layers or something. So specific, I don't think it matters. But in the case of vitals devices, maybe we need to be specific. Thank you.
Okay.
I guess
you.
my
Oh,
my addition onto this, my addition onto this is if we look back, like when Flash was coming into existence as a thing that people were using, there was a lot of work that we needed to take our storage systems from disks to Flash, and I think that's true going forward as we look at like for future storage technologies. We need to decide where our systems currently aren't working to get the performance out of those storage devices, and I think, especially for large use cases, it makes a lot of sense to specialize to the actual devices and the actual storage technologies you're using.
Makes sense. Thanks.
Thank you for this remark. I also agree. So on this note, let's wrap up the session and thank the speakers once again for the great work. Of course, you're free to continue the discussion on the Slack channel, so feel free to ask the authors additional questions and any other clarifications. So thanks everyone for a great session.